All right, great. Yeah, good morning, afternoon. We're over on the Pacific Coast, Washington State to be specific here. Um, just like to begin by saying thank you to Paul, Catherine, and the members of SPED for this opportunity to share a little bit about who we are as a company, why we developed Kohera 3D laser scanning software, and then we'll demonstrate how to use it in real world projects. So a
Uh,
little bit of company history. We are an engineering firm with a majority background in gas and power. Um, our staff consists of experienced and skilled engineers, software programmers, and licensed engineers. In 2001, we became actively involved in laser scanning, and in 2006, we began to work with it pretty regularly and in the engineering and design fields. Um, through this experience, saw a real need for additional tools to work within the CAD environment. And so we began the development of our own software. Just found a lot of things were lacking, things we needed that weren't readily available out there. So that was a step forward we took with our software. So to summarize, Kohera 3D laser scanning software specifically developed to overcome obstacles that we experience while working with 3D laser scans in real world projects. So here on the screen, we have our website. And what we had done was several years later, made a decision to open the software up to the public. The features we developed were first released as separate software modules, which is what you see right here. We have the Kohera 3D piping, the Kohera 3D mesh, and the spectrum. This gave clients affordable options tailored to their specific needs. And for users who wanted everything in a packaged and discounted rate, that would be the Kohera 3D Ultimate, which is just basically everything all included in one. So the main focus, I think, will be the piping, and we'll take a look at how we can use even some of the other modules with that. So I'm going to just click through these and kind of show a little bit, just the various screenshots. So these screenshots just kind of show a little bit about the workflow, which we'll go through, in the demonstration here of the software as well. But taking the scan data, basically taking the points that you want to export and bring into your CAD program. So that would be the third image here. And then the fourth one we see is the center lines for the pipe. And then just the data that we're interested in this case would be the piping. Then there's also the mesh module, which is just a very basic piece of meshing, for the software here, where you can select a series of points and then create a mesh and use that for whatever purposes you are. And the Kohera 3D Spectrum, this here was a way of us being able to take various items in the point cloud and basically like classify it and separate it out. So anyways, just to backtrack here, and so the Kohera 3D Spectrum was pretty much a way of us taking data and separating it into what we call point groups so that you can export those into CAD and be able to turn different layers on and off, or these groups on and off. I like to think of them as layers in a sense. So we can see here we have the entire cloud, then we have the floors and portions of the roof and walls there isolated. And then those items can be turned on and off, and also, again, just exported individually to be brought into a CAD program. The same thing here where we'd modeled the hull for the ship, and was able to break it down into pieces that we could actually work with. All right, so if there's any questions at this point, otherwise I'll just open up the software and we'll start demonstrating the piping. All right, so this here is the Kohera3D software interface. And over here in Project Explorer is where you bring in your scans. You can add project items if you're going to be doing piping, if you're going to be separating or isolating the scan data into point groups. Pretty much all that stuff is first handled here in the Project Explorer.
We're seeing the web page.
Over here is the Project Explorer panel where all of that takes place. So I'll just begin by opening up a project. This is one that I've already created, and we'll just grab the scans and drag and drop it into the scene window. Get some things off my screen that are blocking. All right, so here we can pretty much control like display settings. So you've got subsample levels. If you want more detail, that number can be increased. If we want to see less or have a less, I guess I'll use the word maybe toll on the graphics card. You can make adjustments to how much memory you want to be able to use in those. So anyhow, let's go ahead and fit some piping. So over here in the project items, it's just a folder I created. And here's where I'll create myself a pipeline system. And then I'll drag and drop that into the scene. So at this point, there's obviously nothing in that project items, but we're going to start fitting pipe to the scan data. And this is real helpful if you're doing as-builts or if you're going to create tie-ins and you want to know where that center line is. That is very useful for what we're about to do here. So let's see, I'll just start over here. I'll click on a point and then just center on it. Okay. And right there, we can see that's our starting point, or what we like to call a seed point, of where we begin fitting the pipe. We can see here the size, 12-inch. And I'm going to assign it a line number. Now I'm going to extend it. So I'll just click another point on the piping, and we'll extend that section. And then now we have a fit to that. And when we go and export this to be used in a CAD program, in our case, Plant 3D, we'll have the center line and we'll be able to know the diameter for that pipe there as well. Take this straight section here, and I'm just repeating the process, add in these segments of pipe, and then we'll begin connecting everything with the elbows. So what I had there was a cylinder fit error, which can occur if the point you're selecting has too much noise, or maybe it's just not a very good starting point for making that cylinder fit. And let's go ahead and do this top section. So I like to do all my straight sections first. And then finalize with adding the elbows. So for now, I'll just go ahead and stop there. And then for adding the elbows, we have over here in the piping, there's the insert. And you can choose elbows, there's T's, valves, general fittings, reducers, etc.
When you first select when you first select, it seems to just take a short segment and then you apparently can click again somewhere else and it extends the segment. Why is it limiting itself to the short segment?
I would say at this point, it's still very user controlled. I mean, there may be a situation where that's all we need. Say someone was going to, we needed to tie in just right in this section of pipe, and we don't necessarily need the whole length. So it's just user
Uh,
controlled, and it just takes algorithms surrounding that particular area where you're clicking a point, and then you choose whether you want to extend it or not.
If I can jump in a little bit, John, the general philosophy of the software is that the user is already intelligent, so we don't have to be artificially intelligent about how much we need. Um, we have just a little bit of experience with um, software that tries to auto-select everything that's even vaguely a cylinder, and you get all the systems whether you want them or not. You get railings, you get smaller vessels, and they're all listed as pipe. Um, Kohera3D lets you fit what you need to the level that you need it. It tells you how good the fit is. That means it will let you do things like making center lines from insulated pipe, even though the insulation isn't exactly round. You have to work around things a little bit, but we have tools for all that because we've been in this situation where we've been trying to do that. So basically, Kohera3D lets you use your intelligence and skip the rework from trying to let artificial intelligence do it first and then go and take away all the things it did wrong.
Yeah, something like clear edges, edgewise, which actually costs us quite a bit of money in my experience.
Yeah. And of course, it depends on what you're doing, which one is going to be best, right?
Yeah, it'll find everything, but then you have, like you said, you have to go in and say, oh no, that's not a pipe, that's a handrail. And so you have to clear all of these misinterpretations that the AI does.
So yeah, and that's part of why we start with a small thing and then extend it. Like John said, part of it is just letting you get the part of the pipe that you need. Part of it is letting you be intelligent about how straight the pipe is and how much you care about the original center line. In this particular project, John took a very long fit from one end to the other of a pipe. Now, I've worked with this project before, so I know if he takes too many points along there, it'll read as a very bad fit because the pipe bends in the middle. We can model that if we want to. We'd model it as two pipes and then one very, very cut elbow, right? So again, having more control lets you be more fit for purpose. All right, I'm done.
But is there a way to automate it if you wanted to, and then you could say only find pipes of 3 inch and above, or 3 inch to 10 inch, or something like that?
Well, at this stage, I mean, anything's possible. If there was a demand for that and it didn't cause like what you had brought up earlier, where you get all these different fits, including handrails that you don't necessarily need. If there's a demand and a way to simplify that, then I mean, it's definitely something that could be programmed. All right. So I'm going to just continue connecting these segments. And so the program doesn't know where you want to put the elbow. So you have the set one and the set two where I'm going to, select the individual straight sections of pipe, and then we'll go and connect those. Okay, and then I'll just repeat the process. And this is also where you can choose your elbow, short radius, 3D, 5D, etc. If it's a cutback elbow, all that is handled right here in this drop down. So the program's not looking at what type of elbow is there. The user is making that decision. Yeah.
We still fitting elbows to segments within your software, or is it are you now in Plant 3D?
This is all still in Kohera3D at this stage.
Okay.
We're
And
basically.
I'm looking at an overlap error in a straight segment and a cylinder and an elbow. So
Yes. Yeah.
It
So
trims it when you.
what'll happen
yeah,
after I'm finished is I'll export this into Plant 3 into a program where isometrics and the actual modeling can be performed using the pipe fits that we're creating right here with the scan data.
okay. But normally a CAD software will trim back a straight pipe so that the elbow is properly connected.
Yes. Yes, that is correct.
I think
Yeah,
we'll
that
see that.
happens here
We'll see
too.
that later. Because right now, this is just identifying the pipes in the point cloud itself, which has been loaded into Kohera3D. The next stage is to go into your CAD drawing and import this data. Correct?
Correct, yes. And then obviously in the piping program, that's where you would have your specs. So you would do all that design work where you can actually, print out the isometrics to have things built. All right, so at this point, we would just come over here, well, save the project, and then so first I'm saving the pipelines object that I created, and then the project itself. And then for this pipe segment, you can export it as a DXF or an OBJ. If you export it as an OBJ, well, we'll be able to see the differences here shortly. So I've already done an export, and I've already exported a segment of the point cloud. So let's just come over here, and I'll show you how that's done too. But so here I'm going to attach the point cloud, and I think that's an RCS. Oh, where are we? Here we are. This one. I like to take my point clouds and add a little bit of transparency to them. So this pipe segment we were looking at earlier that we did all the fits for, I've already exported that, and I'm going to just show you what it looks like when it's brought in to Plant 3D. So we'll insert it as a block. Oh, wrong one. Tell you what, let me just export what I have. Start fresh. Okay. So this line here, this is the center line for that section of pipe. And these pieces here give you the actual diameter. So we can do one of two things. We can just check the distance on it to give us the size of that pipe. We also have in the layer palette, you can click on one, and the line type scale, we set that to tell you what size pipe it is as well.
Yeah, that's in the properties palette.
Yes, correct. So either A, we can now start modeling our pipe by simply snapping to the endpoints. like so. Or what's really nice is Plant3D has what's called a line to pipe. So I'm going to select everything on that line there and then just click line to pipe. Let's turn the point cloud back on. And there we go.
So does the center line that was there before, does it remain in as part of that drawing, or does it removed when you do the line to pipe?
That's entirely up to you.
Okay.
It's a Plant3D setting.
Yeah, so there's also, it has its own layer and it's locked. So the center line there, that's on this layer, line one, and it's locked to keep it from being deleted, but you can delete it if you don't want it there anymore once you're finished with it.
Or you can unlock it to make changes.
Yeah.
But as someone who was working with this in the early development stages, we found that having it come in locked saved a lot of accidental errors.
Okay, so that's just one segment there. And what I'd like to do is, so we have over here where we took the scan data. We wanted to export that without the ground and everything else so that we can actually really visualize and just see everything a lot more clearly. So the way that pipe is separated, I mean, there's a couple of things we can do. Either one, you can just go under your shape tools and grab a selection tool. And then you can just select a set of points that you want to export. And you can do that. Or you can create what's called a point group. And I've already made one here, so I'll just drag and drop that into the scene. So what I've done here is I've taken all this stuff out here. I don't care about that at all. So now I can turn that off. It's basically on its own layer. All right, so let's do this. So here's the Scene Explorer where I can pretty much control the display of what I want to see and not see. Turn those items on and off. So I'm going to just turn off the pipelines for now and show you how we would go through making a selection. So I'm going to take this next section of pipe and I'm going to assign it to its own group, and then that can be exported and brought into CAD individually without the rest of the data. They just begin by making a point selection, which means I'm going to end up grabbing some things behind this section of pipe, some items in front of it, and then as we go through, we'll clean it up before we do the final assignment for that. I really like the polygon tool. It allows me to make a better selection. Okay, let's grab this here. Okay. Going to switch over to just looking at the points that I've selected because I know that I grabbed some things that I'm not really interested in. And then I'm going to just hold down the control button or control key and deselect what I don't want. Okay, so going back over to Project Explorer, I'm going to click on the point group that I created. And this is where you can make all your names and as where all the point assignment is going to take place. So I can make a layer or a point group that's called walls, ceilings, floors, piping, I can label certain pumps and then just assign these selected points to that particular group. So over here, I'll just call this piping. And let's make it yellow. And then now I'm going to assign it. Clear out my selection and then switch back to viewing all the points. So here's that pipe that we just assigned to its own point group. And then I can take this one and we'll just call that piping. Do an export of just those scan points. And then what I would do is pull it into recap, since that is the format that Autodesk supports. I think I might have already brought this in, but let's see.
One of the nice things about Kohera3D is that it can work with any software that can receive a DXF for the centerlines or an E57 for the point clouds. So if you don't happen to be working with AutoCAD, you can still use the exports in whatever you are working with. Kohera3D itself is completely standalone, so it doesn't lock you into exactly the workflow with other software that we're using.
There are a few questions in the chat, if you perhaps want to address them.
Yeah, there was one question about, is there a minimum size range that the cylinder fit works on? Does it recognize 1/2 inch tubing?
Oh, yes, we can do the small pipe conduit. Actually, let's switch back over.
It's all about your scan quality at that size. You can get very small if you have the points for it. At 1/2 inch, it's going to depend a lot on your scanner. You also may end up using, instead of the sort of the one-click tools, you may have to use the fit pipe to points to sort of, it's a tool for helping along a cylinder fit where the auto fitter maybe doesn't work as well. But yeah, we're set all the way down to 1/4 inch, and it will also allow diameters that it doesn't recognize as default pipe, which you can see in the pull down there, unknown inches is allowed. And again, that's because we want to allow the user to use their intelligence. If you want to fit pipe over what's actually, you know, an insulation jacket, you can. It obviously the diameter won't be right, but it'll still give you the correct center line. If you want to try and fit 1/4 inch tube and you have the points to do that, you can. If you want to model railings with the pipe fitter, you can, you know. You can go ahead, John.
Yeah, so the 1/8 inch is the smallest size, and then we have it all the way up to 88 inch. And that can be used for just various things. We've done some cylinder fits, you know, pipe fit, but cylinder fit for large tanks.
Mm-hmm.
And that's really helpful for that too. So, I mean, obviously there's no limit. You can just go up to the unknown inches and you'll still be able to get your radius values and things right up in here.
Yeah. Yeah, we've used that to get center lines of, you know, vessels, heat exchangers. I have used it on round pipe supports. Again, in this project in particular. I see in the chat somebody's asking, does the point cloud quality affect the use of the tool? The point cloud quality affects how easy it is to fit a cylinder. Obviously, the more points you have and the more cylindrical they actually are, the easier it is to get a fit. But again, we've given ourselves the tools to work with places where it's not perfect. If necessary, you can go in and select around, say, a reflection that bends the wrong way, apparently, and say, look, those are not real points on the cylinder. Let's just not use them, and then fit a cylinder anyway. So basically, the higher quality your point cloud, the easier it'll be. And if the point cloud isn't that great, if the alignment maybe wasn't that great, we have all the tools we need to work around it. And it'll take maybe a little longer, but we can get there when we actually need to. And when it's okay to be a little less precise, we can just be a little less precise. But when we need to be precise, we can. And of course, that's very important in that marine piping, where you're trying to connect to a flange that was stovepiped by somebody with a come along and a sturdy wrench 40 years ago, and then left to rust for 20 years, and again, if you need the precision and you're willing to take a little time to see exactly what's there, if you have a close point cloud, we can do that, and drop in and bolt up, things with, 4-degree angles and all kinds of crazy stuff. If you don't need that precision, you don't have to take the time. You can just throw it in quickly, accept a little bit of a higher error message, or a higher error, what's the term I want? A little bit of a larger RMS, and just, get on with your project. Somebody's asking if there's a plan to export PCF files. If it's not proprietary and multiple people express interest, we can add formats.
PCF is a format that I think it works across multiple CAD systems.
Correct.
But it's basically when you run an automatic ISO in Plant3D, it uses a PCF file. I think it stands for piping component file.
The DXF can go into anything because that is an exchange format. So you can put it into Plant3D, you could put it into an architecture program, anything that has any kind of piping to it. It'll give you all the design points you need to turn it into smart piping quickly in whatever software you're using. John hasn't demonstrated it because he's obviously trying to do a quick demo, but we have ways to put in just design points for valves or other fittings quickly. And again, it's not designed to put in the spec for whatever component is there. It's designed to show you where the design points are. So when you go into your actual piping app, you can do it quickly and easily there.
One of the other questions in the chat was about what other kind of pipe fittings does it model?
Yeah, we're using the basic ASME standard for, so basically, if you're adding an elbow or a T, then it will get the ASME standard leg lengths on the T's and things like that. If you're putting in valves or fittings, you adjust them yourself to match the point cloud. When you're drawing pipe in just a greenfield design, you don't draw arcs. You know what I'm saying? You go from design point to design point as if it was square. And where the leg lengths fall are design points, but they're not the ones that you normally use to draw the pipe. You go from the sort of imaginary corner of the elbow. That's how you work with the center lines we export as well. So if you're using a different spec, maybe the leg lengths aren't quite right, but also they don't necessarily matter most of the time, because you can just go from corner to corner like you would if you were drawing new pipe, except that because we fit the existing condition, right? Because we're not drawing new pipe, we're as-builting. If it's 7 degrees off, we've got that 7-degree angle that's very hard to reproduce without the center line. So we don't use specs very much in Kohera3D because we're not trying to do the smart piping element.
Right.
We're trying to make it possible to as-build accurately.
The other part of that question was, does it model reducers and flanges.
You can insert reducers, basically a valve symbol. It's really just a symbol because again, it's there to show you the design points. So you can put something in, it'll look like a valve, like a P&ID symbol for a valve. Or you can put in what we call a general fitting, which just looks like a rectangle. But the job it does is it shows you where the design points are. So when you're in CAD and you have an exact spec and you've put all your customers' custom valves in, you can say, okay, I have a valve that was a 12-inch footprint and I can see the actuator in the point cloud, and this is where it goes, and you click and drop it in. It saves you from trying to work with your valve, exactly where it needs to go. In the point cloud in Plant3D that doesn't actually deal with point clouds very well, even now. It lets you do that, figuring out exactly where it is in the point cloud program, and then bring that data to Plant3D so you can do it fast. And that's why our primary export is a centerline and not a fully modeled pipe, because a fully modeled pipe is actually harder to work with when you want to turn it into a smart model. Exporting for visualization, that's what the OBJ is for.
Yeah.
I can demonstrate inserting a valve if you'd just like to see how that works. Might as well do that. So just under the piping insert, I have a pipe selected here and just valve. So it just randomly places it on the center line of that pipe segment. Let me do what's called a spotlight and get a little more detail. And then at this point, you would just drag it and try to line these up with where the face of the flange would be. So this is going to give you a rough estimate of the length of the valve, which you can go and you can confirm in your piping program, but it lets you know when you're working in Plant3D that you do have a valve there. So you can use that as just confirmation, and that'll come out in the export.
And again, how accurate you can be with this depends on how accurate your scan data is and how accurate your alignment is. And how much time you're willing to spend on it. If you don't need very high accuracy, then it's easy and fast. If you do need high accuracy, it gives you the tool to actually get that. Yes, fit for purpose is one of Daryl Johnson's favorite phrases for this.
Yeah, let's just take a look at the meshing. And I know that may seem irrelevant for piping, but it actually can be used just for visualization of where something is without having to model it.
Like we might mesh the pipe, or I'm sorry, the pump, and then in Plant3D model just the flange of the pump and then use the mesh object to make a custom object. Again, it's all about getting the visualization or getting the flange position that you actually need, and not doing more work than you need to, not putting more complication in your model than you need to, but having what you do actually need.
Pretty much you're selecting what points you want to mesh, and you can go in and modify that. So for example, I'm just going to view at the selected points, which would be the platform as well as the pump. And so if you didn't want something to be included in your mesh, you could just deselect it, remove it. So let's do a Control Z. And then under models, meshing tools, and create a new mesh set. And then we determine a subsample level. So how many points? Do we want to use the max amount of points or do we want to reduce it? Like, it's a basic meshing capabilities. So obviously the more points, the more representative it will be of what's actually there. And then you just generate that mesh. And let's see, I think I had already done this earlier and then turned that layer off. Here, yeah. So I had actually done this already. So let's hide that. So there's the mesh. And then that can be exported. So obviously that would be an OBJ. And then, for example, we come over here to this pump mesh drawing. There's the mesh of the pump, and then the tie-in and the pipe. That's
The
a
trick I
great.
use a lot is to put high density point clouds or high density mesh, um, just exactly of the flange itself, and then a much lower one elsewhere. Um, it's one of the tricks I use when I'm doing that sort of uh, marine piping, for example, where I actually need the 2 and 5 degree angle things. I will export every point the scanner caught for just the flanges, and that'll be one point cloud that I export. And then I'll turn that off and export the actual piping at maybe a tenth the density, because I don't need all those points in Plant 3D, but I do need to have every point I can see on the flanges themselves when I'm modeling a difficult connection. You can do the same thing with meshing. The samples are in black and white, partly because this data was not scanned in color, but I believe we can map the scan colors to mesh when we actually have them.
When you scan in color, at least in my experience, it takes at least twice as long per position. So a lot of people do scan in black and white just to save time. It's better to have more scans than fewer, obviously. But color looks nice, but sometimes it just doubles your scan time.
And your file size,
Yeah.
the load on your computer when you're trying to work. Now we do obviously support color when the scan has it. So John hasn't used that visualization mode because, again, this data was black and white when it was taken. But you can absolutely see all of this in color if you have scanned in color. But you can also do what I find much more useful, and that's match isolation colors, pipeline colors, so that instead of seeing the facility as it really was, you see it highlighted by system or by what's in scope and out of scope. So again, it allows you to do what's best for purpose, what's best for the project visualization. And then when you've got all of your piping, you can export a lower density scan, say to Navisworks for pure visualization. You put all the color in that. I asked our programmer about the meshing in color, and we think so, but we'd have to find some color data and test it to be positive, because we don't work with color data very often in our actual projects. We support it, but we have not found it actually to be useful.
Is there any tool for structural members?
Structural members are a little more difficult to identify, so we're not there yet. We are now in beta just with a proper plane fitting tool, which we expect to be used more for things like bulkheads, walls, pass-throughs, planes of rectangular equipment that has nozzles on it, sort of quick modeling of electrical boxes. That sort of thing will come out very soon, and that will allow you to fit, for example, the surface of a I-beam that you need to land on. as well. But in terms of doing structure the way we do pipe, we're not there yet. Similar to how we recognize cylinders and we know how piping goes together, but we don't necessarily try to recognize a spec. With beams, a lot of the time you have to know the spec to fit it properly. And so John's demonstrating the plane fit here. So
Yeah,
again,
this is
go
in
ahead, John.
beta. Yeah,
Yeah,
it's still in beta, it's still being worked on. So, I mean, yeah. A couple other things I'd like to mention before we run out of time about the software is, I mean, the licensing is really simple. If you have the program on your work computer and you want to have a second copy, say on your laptop, you're going out on the road, it's real easy. You can deactivate the license either from the software at work before you go out on the road, or you can do it online and then just drop it in and reactivate it. So it's really simple in that regard. There's a support page we have that has all the tutorials, online documentation, and when there's an issue with someone has a scan and something's not working right, you can upload files and send those to us, and we'll take a look at it and get back to people really quickly.
Thank you, John, Deborah, and Daryl for the demo of Kohera3D. Do you have a demo available?
Yes, there is a 14-day trial on basically, well, the Kohera3D Ultimate. So you just click on that and then click the download free trial. The trial does require activating the license, and that will be on the account page when you go in and add in your information and download the software. Again, if there's any questions along the way, just reach out to us and we get to people, back to them right away. So you won't be waiting very long to hear from us.
You can hear me. This is Daryl Johnson.
Oh.
So
Yeah.
unfortunately, the meeting coincided with a scan job in Seattle. So we're set up at a site, but I just want to and I've been able to listen to part of this. I just want to real quickly say that we're always looking for feedback. And so with that 2-week trial, for those who provide feedback to us, with whatever, just showing that actually use the trial, we extend that trial another couple of weeks for sure. So I appreciate all your interest in this, and I'm going to go back to mute.
Thank you, Daryl.
So thank you for attending.
Okay, Catherine, Paul, thank you very much, and the rest of the members there. We really appreciate it. Have a great day.
Thank you so much.